Hi guys, welcome to my channel. Today I have selected a question in 2009, question number 53. Is a good question again. Water in tank is uniformly bubbled with small identical air bubbles which having volume V0 as shown in the figure. Okay, so every individual bubble, small bubble, has a volume of V0. Alright, a sphere of mass capital M and volume V is floats. Here see, this is mass capital M and volume is capital V. Okay, floats in water as shown due to the attachment of certain number of air bubbles in the surface. Okay. If dW is the density of water and the minimum number of air bubbles that is needed to be attached to keep sphere floating in the water. Now here see, now this is partially immersed, right? Now you have to make this to be float. And you have to make this to be float. You have to move this guy to be top. Usually you should think like this. Now here see, the weight always downwards, weight, and you have an upthrust. If upthrust is greater than the weight, then the particle, then the object will move up. If it works other side, upthrust is less than the weight, definitely it goes in. Now it is already in this stage. You have to make this guy to be up. You have to move him up. You have to move him up. Now practically what they are trying to do is they are trying to make this water to be bubbled, and they are trying to make some bubbles to get sticked with it. Sticked on. So bubbles has a volume V0. So when number of bubbles increases, attached with it increases, means what happens is, you know the formula for upthrust. What is upthrust? Immersed volume, density of medium, and gravitational acceleration. So rho g they remain unchanged. Unchanged rho when bubble is reduces, but again here is given as dW. They didn't talk about the density. Here see, so now when the volume increases, automatically upthrust increases. So you can move this guy up. The idea is you should have to make some bubbles to get attached with it. So automatically the volume increases. When the volume increases, upthrust increases. Upthrust increases means this guy will move up. Okay, so let's do like this. Now let's think as this bubble is almost here. You have attached some bubbles. You have attached some bubbles with it, and it is there like this. Now the upthrust is here, weight is downwards. In equilibrium, they have given number of bubbles attached is, let the number of bubbles attached is simple integral diagram. Now in equilibrium, let me say in equilibrium, weight is equal to upthrust. Weight means weight of his mg, total weight, is equal to upthrust. Weight of metal plus weight of bubble, total weight of bubbles plus equals U upthrust. Upthrust means initially immersed volume. Volume of metal plus volume of bubbles, not only one bubble. Let me say volume of bubbles means in number of bubbles are there into density of medium into G. I'll substitute. Here see, before that mass of metal is given as m, but this is air bubbles, no, so you can neglect the weight of it. Air one. එතකොට capital M into G, volume of metal, that is V, plus volume of bubble is V naught, but in times, that is equal into density, that is dW into G. Density is dW into G. G cancels. So M equals V dW plus in V naught dW. I'll just try to subject design, okay? M is equal to M minus V dW over V naught dW. Okay, I have got an answer, but still I can't find the answer. Yes, I have the answer, but inequality kattamai dila diyane. Now here see, now let's argue. When number of bubbles attached with this is equal to this volume, equal to this amount, it means the bubble, the metal will be in line as seen in this figure 2. Again, when the number of bubbles is higher than this amount, it has to be float, no? Number of bubbles should be higher than this. Should be higher than what you calculated. If the number of bubbles attached with this metal ball is higher than this amount, means the upthrust is higher. Automatically it will float. So the best answer is, according to me, the best answer and the scheme answer is 2. Hope you understand. Bye for you all.